Hey class, so here is another type of factoring that we do. It's called differences of square. So if you happen to have a polynomial that has a certain pattern, for example, if you have a squared minus b squared, you can use this form to factor it out. You would just do a plus b and then a minus b. What does that look like for our practice here? Well, if you see here, x squared is a perfect square. Anytime you have x to an even number, it's a perfect square, okay? And then you have 4, and 4 is a perfect square as well, because square root of 4 is 2. So the long way is you would just take this, and you can say x squared is just x squared, but you can write 4 as 2 squared. So you have two things squared, which means that I can go ahead and use my little formula that I have there. So that would say x plus 2 and then x minus 2. And that's it. It's factored. Same thing here. I know 81 is a perfect square, so I can factor this out to say n plus 9, because the square root of 81 is 9, and then n minus 9. Here, I can go ahead and use the formula because 25 is a perfect square and negative 49 is also a perfect square, and it's being subtracted. So we're going to say that 25, I'm going to do the long version here. I'm going to actually write it out. So 5x quantity squared is 25x squared minus, I can say this is 7 squared. So there you go. I have two things squared, so I can now go ahead and factor this out to say 5x plus 7, and then 5x minus 7. Let's do this one. So here we have 9 is a perfect square, so I can say this is 3b plus 10, square root of 100 is 10, and then this is 3b minus 10, okay? Just keep going right here, I guess. So this is 4a, square root of 121 is 11, so plus 11, and then this is 4a minus 11. So here we can say that this is 4a. I can also actually say plus first. Oh, I already did plus. You can go either way. You can say minus first or plus first. It all comes out to be the same thing. Okay? 4a plus 12, and then 4a minus 12. Now, for number 7, it says k squared, which is a perfect square, and then 25 is a perfect square, but it's not the difference. So therefore, I cannot factor this out. I cannot say plus or minus. It's just, when you cannot factor something out, you would say that this is prime. Okay? This one, there is a difference. I can go ahead and do this. So this would be 9x plus 4y, not 4y, sorry, 9x plus 2y times 9x minus 2y, and that's it. And then the last set of problems that I have here is, well, 2 is not a perfect square, neither is 72, but I can factor out a GCF first, because the greatest common factor here is 2, so that's n squared minus, let's see, what's 72 divided by 2? That is 36. And then now I do have perfect squares in here, so I can go ahead and factor them out. So this is going to be the same as n plus 6, and then n minus 6. That's it. For this one, the GCF, remember, you can go ahead and just use Desmos to find the GCF, just type GCF, and then put 18, 50. So the GCF is 2, so I can factor out a 2 first. So 18 divided by 2 is 9, and that is a perfect square. Squared minus 50 divided by 2 is 25. So these are both perfect squares, so now I can go ahead and factor this further. So 3x plus 5, and then 3x minus 5. I'll just finish the last two here. The GCF between 80 and 125, let's see. 80, and 125 is 5. Also, if you look at the variables, n to the fourth and n to the second. So the most I can take out is n to the second, okay, from both of my terms. So 80 divided by 5 is 16. And then n4, take away 2 n's, or n2, so that would be n2 left. Because n squared times n squared is n to the fourth. Minus 125 divided by 5 is 25. 25. And then the n squared comes out. There we go. Let's finish this problem by using the difference of squares. So this is 4n plus 5, and then 4n minus 5. So for this one as well, I will go ahead and take out, I think the GCF here is 8. And then 32. Whoops. Yep, the GCF here is 8. And also, if you notice, there's a y that's common to both of my factors. I can take out the y as well. So you have here 8 divided by 8 is 1. X squared stays, and the y comes out, minus 32 divided by 8 is 4. Take out one of the y's, so you have y squared left. So look, everything is nice and perfectly squared inside. Okay, so then you would do 8y, x plus 2y, and then x minus 2y. Alright guys, so that's how you factor if you happen to have two perfect squares with a minus sign in between. Alright, thanks for watching. Bye.